Hello, everybody. Welcome back to the Routing Loop. I am joined again by Justin Davies. Say hi, Justin.
Hey
And
everybody.
and also by Eve. Eve, say hi.
Hi.
And we're going to talk today about a little bit more Lattice. Usually, when you see Justin, you usually, it's usually a bit of stuff of Lattice and that. You have our folks joining up. Hi, Ken. How you doing? So what I want to do is, even though Justin, you've been here a few times, and Eve, I think this is your first time, right?
This is my first time, yeah.
Yeah, we'll just
Excited.
do a little round of introductions, and then Justin, I believe you're going to kind of kick it off. And again, for everyone watching in the audience, please ask your questions. We'll bring them up as we go along. They're prepared to be interrupted. But Justin, please tell us who you are, what you do, and why you're here today.
Sure. So hey everybody. I'm Justin Davies. I'm a product manager here at Amazon, covering application networking. VPC Lattice falls straight in that category. How do we provide connectivity, but not just connectivity, load balancing, service discovery, authentication, authorization. So it's kind of a hodgepodge between networking, application type integrations, and security, I would say. So I've been doing that for about 8 years now.
Nice. Eve, why don't you tell us who you are and what do you do?
Sure. So I'm a specialist SA, working out of Munich in Germany. And I'm both dealing with containers and networking. So I'm actually in my career always flipped back and forth between the application side, the networking side. And so that's why I'm also very excited about VPC Lattice as a service. Yeah, in the last 2 years, I spent a lot of time with the service.
Nice. So
Well,
app networking.
I want to call out one thing for Eve, just because there's so many people that are like really strong networking folks, and then there's other folks that are really strong container folks, and there's like a few people that are like okay at both. But like Eves has been super deep on both sides, and so I would say he's like
Yeah.
that kind of really rare breed where he's an expert at both.
Awesome.
Thank you, Justin.
And you're going to be showing us a demo too later on, right?
Exactly. Yes. Hands on.
Perfect.
So,
Okay. Yeah, I was
demo
going to say
gods.
either one of, yeah, I know, right? We have to make sure the chaos monkey doesn't bite us here. But for either one of you who wants to pick this up, because some of our audience, are just starting out in AWS networking, and of course, we have folks in our audience that are fairly advanced in networking. Can you kind of just give like that high level overview, like what is Lattice and what is its purpose?
Sure. Well, do you want me to go ahead and share my slides? Because I can maybe kick it off like this. And so these I just stole from the reInvent Chalk Talk. Chalk Talks aren't recorded, and so you kind of have a set size of room. There's usually big long lines outside of them, and if you don't get in, well, you miss the content. And sometimes they're some of the best ones because you get customer conversations and questions and all that kind of stuff. And so I'll start with this, but then we can kind of move around as needed, just because I think the first slide is just a recap of what VPC Lattice is. I know I've seen a lot of the faces and names pop up that have been on several of these ones that have been on here from before. So I don't want to spend too much time on this, but there is tons of material out there, tons of great blogs. If you just search VPC Lattice blogs, there's even a consolidated link for all the blogs and content and things like that. And we've put them all together in our VPC Lattice homepage. And so maybe I'll share a link here in just a minute once I stop talking. But VPC Lattice, like we were talking about before, was an evolution of kind of how we were seeing customers adopt these modern architectures in the cloud, right? Customers don't use one VPC; they use sometimes hundreds of thousands, and those can be very tiny VPCs, those can be very big VPCs, they can be all over the place. And so network connectivity was an absolutely crucial need. So we knew we needed to kind of say, okay, what does modern connectivity look like? The other pillar we kind of saw when we were looking at architecture several years ago was, well, on the other side of that network connectivity piece, people have load balancers, right? Like every single workload, whatever it is, has a load balancer, except for maybe one type of workload that we'll cover in a little bit here. And the other things are kind of the basic stuff, right? It's like, okay, so what about securing these workloads? What about observing these workloads and all that kind of stuff? So we wanted to bundle in a solution that kind of made customers have an easier experience doing this, so they didn't have to have all these specialists just to go and set up their apps across VPCs and accounts and follow best practices. And so that's what VPC Lattice was. You could think of it as this kind of like big, fully managed application layer proxy that all of your VPCs are attached to. You tell us about what your services are and what your applications are, and then we handle the routing, the connectivity, the authentication, the authorization, and everything for you. And so it's just this kind of big, fully managed service. So that was kind of the intro. And then I could dive into kind of what's new if we want
Go
to
ahead.
do that.
Yeah, go ahead.
Okay.
Why don't we dive into
so
what's new? Yeah.
Perfect. So this is kind of the flow of what the Chalk Talk was at reInvent. And again, if you haven't been to a Chalk Talk, I definitely recommend it. It's our favorite session usually. Like Jamie, I know you've done a ton of them.
Yeah, I love them.
To me, it's my favorite session. I like it more than doing breakouts, just because the customer engagement is just so lively, you know. Okay, so when we first launched, when I said it's an application layer proxy, you know, we were doing HTTP type connectivity between services. So HTTP, HTTPS, that includes gRPC, and it was very much that kind of API centric connectivity across VPCs. And we integrated with almost all of the compute platforms. You could natively have a service running in Lambda and EC2 with auto scaling groups. You could have IP targets. You could also have Kubernetes containers and pods, and Kubernetes services actually natively register to your VPC Lattice services. And so we had this like native integration where customer didn't have to necessarily learn all this new stuff. They could just go to the platform that they're using and publish their service with VPC Lattice without having to learn something new. So the Kubernetes integration was great. It was really kind of a big bummer at launch, though. We didn't have native ECS integration. There was a way to do it. We allowed customers to attach an ALB that was directly attached to their ECS service. And so as ECS services spun up tasks, it would go and register with the ALB, and then you would have the ALB attached to the Lattice. But as we were talking about, you know, Lattice is a proxy. And so it's kind of this like weird hodgepodge design where you had a proxy in front of a proxy and then your ECS services. Just not ideal. So that was not on purpose. We just ran out of time. We were like, let's get this out there. So we fixed that. We've got native ECS integration. I'll skim through kind of what that looks like in a second. TCP resources. That was another thing we launched just over at reInvent, actually.
I got to do the breakout.
As I said before, you got to do the breakout on that. That's right.
Yeah.
And you should copy in that link too to that reInvent talk, because you guys did a great job going over all those things.
Absolutely.
So TCP, when we first launched, it was HTTP only, right? That was the big focus for us. We wanted to be universal connectivity, but again, stepping stones, right? Like we're just each time we can release. So we now have TCP support. That was our number 2 feature ask. VPC endpoint support. And again, I'll jump through a couple of these things in pictures in just a second here. So, you know, I'll tell you again, and then I'll tell you one more time probably. This is a very interesting feature. It's a very boring feature if you just take it at a glance. All it means is the ability to put a VPC endpoint in front of a service network. But it opens up a whole bunch of really cool use cases. And I'm going to show you some of those in a second, but just the high level is that now you can access your VPC Lattice services and resources from on-prem, from across AWS regions, from across the transit gateway, things like that. And you can also access multiple service networks per VPC. So this was probably the biggest reInvent I've being here at Amazon almost 9 years now. This was a big, huge launch for us. We covered our top 5 PFRs just with these releases. So it's kind of a huge event for us.
Yeah.
Okay, so native ECS integration. I kind of talked about it a second ago, but here's the picture of what it looked like. If you're familiar with Lattice and you've been around for a little bit of time, you probably saw that VPC Lattice consists of listeners, rules, and target groups. Very similar to a load balancer, right? Because it is a load balancer. It's just kind of a more magic feeling and simpler load balancer. But it still has listeners, aka port 443, port 80, so on and so forth. It has rules. Okay, if you're /path1, go here. If your user agent equals Justin, then do something different. And then target groups. And those target groups is what you attach to these different things. And before this native integration, you put the ALB right here. Now you can just natively have your ECS task directly attached to Lattice, Lattice target group. You could do that in the ECS console, so your developers or your person that owns the service doesn't have to necessarily learn Lattice to do this. And they can kind of really share that persona offload, right? Like they can do their portion, you could do your portion, and you guys have a very seamless experience here. It's not anything more fancy than that. It's pretty basic and simple, right? And I wish we had this before, but huge feature, pretty basic idea though. Okay, and this is what Yves is going to show us in just a couple of minutes here. One thing, if you're, again, pretty new to Lattice, keep in mind that we do want to abstract your ability to use whatever compute platform you want, right? So one of the things that we saw over time was customers would maybe start out with a lift and shift model, get the thing in EC2. It's just this big web server on EC2. And then they figure out, okay, you know what? There's portions of this app that would make sense in Lambda. There's portions of this app that make sense maybe on Kubernetes or ECS, or maybe it's migrating from Kubernetes to ECS or vice versa. Any of those models, Lattice abstracts all that, right? Because a client would just be connecting to this Lattice service. And then with these rules and target groups, you can mix and match however you see fit and send it to whatever target groups you want. Okay, so TCP resources, this is a really interesting one. And if you've been around for a while, you've probably come across private link and private link's ability to have an NLB on one side, which is a TCP load balancer, and then basically an interface on the other side. And everybody loved this, and it was one of our fastest growing services just out of the door, right? Because it just allowed you to share these private resources, the IPs could overlap, and it just made things really simple. Whether you were a partner sharing with a client that was in a different organization, whether it was the same organization, all those kind of things. It was a great way to kind of sidestep even that gateway and things like that. If you were just looking for that kind of IP level connectivity between two VPCs. The thing that it didn't handle too well is data-centric workloads. It was, again, still really good for those typical TCP transactions where you got a client-server relationship. Data workloads can be really, really funny. They change very frequently. Sometimes it involves this kind of like broker negotiation of like, hey, where is my partition I'm looking for? And then the broker will say, oh, go to server 5. And if the client tried to connect to server 5 and it was behind a load balancer, the load balancer might say, go to server 10. And it won't care that the broker told you to go somewhere else. And so it was really not a great fit for a load balancer. And so when we looked at TCP, what we call VPC resources, the launch that we did at reInvent, we said, can we solve this in a different way? Where we just said, take the load balancer out of it altogether, just allow this one-to-one style connectivity and do NAT between the two, okay? And so this is what VPC resources is. It allows you to pretty much define anything that's TCP, whether it be some sort of Kafka cluster, some sort of database that you own, could be an RDS database, and actually share that via VPC Lattice or over private link. You can do both of those. You can mix and match.
Hey, Justin, we got a question here. Is this supported across Europe or only in a small subset of our regions? How far is this? Where is this deployed in the AWS regions?
It's deployed in quite a few regions. I don't know how many in total right now, but in the What's New blog, it'll say the ones we're actively in, and we're rolling these things out constantly since reInvent. So maybe we could find the What's New blog for VPC resources.
Yeah, let me grab that.
Or TCP support for VPC Lattice. Both of those will tell you the regions that it's in.
Yeah.
So VPC Lattice is
It's
almost
definitely
in every
already
single
in
commercial region.
It's definitely already in Frankfurt and in Dublin. I think it's in London too. But definitely Ireland and Frankfurt are already tried and worked with it.
Yeah, the typical ones that you see, like the big ones, we usually launch almost everything in right away. And then the other ones kind of just trickle in based on demand and how hard it is to kind of roll these things out. So if it's not in your region already, it will be shortly. We're rolling these things out. So that was TCP resources. This we're going to give you a demo of, because not only does it make TCP resources basically like anything you want to share, as long as it's TCP today, you can kind of get it. And so if it's an HTTP resource, you would still use VPC Lattice services. But if it's anything else, you can use these TCP resources, and that can be for accessing things on-prem as well. And one really cool thing that I'll mention, because it's again, if you've been around for a while, you've probably asked one of your account teams or one of your kind of solutions architects you've worked with in the past for DNS as the target or DNS endpoints, right? It was a huge feature request on network load balancers for us. The ability to basically, instead of having an IP target or having some like automation that went and had a Lambda function going and looking up DNS targets and then updating the IP targets of an NLD, with resources, you actually have the ability to do DNS-based targets. And so we will handle all that kind of translation to the IP and all that kind of stuff. So you can just put the endpoint DNS, and we will register those TCP DNS targets as targets of your VPC resource.
But it's also huge.
It's one of those ones where it's like, it was boggling my mind during reInvent, like how we could tell the story of everything that launched. And like,
not have one more thing huger than the other. Yeah.
Yeah, it's like, how do you lay this out without sounding overwhelming? It was just a lot there, and it's just like, how do we break this down? At some point, you just got to be like, okay, let's just list them all. Let's just talk about them.
Yeah, exactly. And one thing too, I just want to mention for those listening, for all these things that Justin's talking about and all these different features and releases, working with ECS and working with VPC Lattice endpoints, resource endpoints. This is a culmination of a lot of different teams all working together. It's not like we have, one big screen where we can just, touch something and throw it on there and say, okay, now we can add this feature and this feature. It's like a lot of different moving parts, a lot of different cogs, a lot of feedback from you as our customers. Like, what is it? 95% of all of our services and features are customer requests, something like that. So this took a lot of time to come to it, and that's why we're so kind of excited about it.
Yeah, and there's a question that came up there about talking about DNS. Can you elaborate a bit more about this, please? There might be an opportunity when we're setting up, when Yves is showing the registration of the target, we can show you kind of where the DNS part makes sense. But essentially, think of it like this. Let's say you've got something on-prem, and you've got maybe a load balancer on-prem, or you've got some sort of server on-prem, and it's myserviceonprem.com. You can actually create a resource with the target being myonpremservice.com. And as long as that VPC where the resource is configured that has connectivity over direct connect or VPN or something like that to on-prem has a resolution that resolves to that IP address, you will be able to route to that, right? You will be able to actually connect to that without configuring the IP target of individual servers or anything like that. We will go and do that for you. And so it's really just kind of the ability to put a DNS or FQDN-based endpoint as a target of a VPC Lattice resource instead of an IP address or something like that.
Yeah, but one thing to add to that, I think, is that it needs to currently be publicly resolvable, right? So this is one of the requirements that we have today. So in your on-prem case, right, you would have to be able to publicly resolve, but to private IP addresses, which a lot of services actually do. If we look at RDS as an example, it resolves publicly but returns private IP addresses. So it's not unusual to do that.
Yeah, and that kind of follow-up question there around the 169 link local IP address space. That 169 link local space is used for VPC Lattice resources, which is great because it's a very security-focused feature, and it's also a ability to kind of be separate from your own IP space. So you never need to worry about overlap. The downside of it is that it only worked within the VPC. That link local space, if you look at the RFC, it's basically non-routable space. It means you can't route, you can't leave. And so we wanted to keep that kind of functionality. It only works within the VPC that you're in. So that as long as you're in that VPC, the client's in that VPC, then you can connect. If you're outside of there, you can't get to that 169 address. You can't even route to that 169 address over VPC peering or transit gateway or anything like that. The downside of that, it was great from a security perspective. The downside of that was that you just couldn't connect to it from on-prem, right? Yeah. What if you needed to get to it from on-prem? What if you needed to get to it over from a different region, over Cloud WAN or something like that? That exact problem, and thank you for the lead-in, is why we built the VPC endpoint support. So VPC endpoint support, which I'm displaying on the screen now, is that simple, another very simple feature, very basic, but solves a lot of really good use cases, is the ability to put a VPC endpoint, like a private link VPC endpoint, in your VPC in front of the service network, okay? And so instead of using the link local address, you can have an actual IP address from within your VPC that is reachable from on-prem, VPN, direct connect, transit gateway, a different region. And so it allows you to expose this into different ways. That VPC endpoint supports security groups and all those kind of things. So all of your typical stuff works. It gives you kind of that consolidated endpoint for a bunch of VPC Lattice services and resources.
The other thing too is, Justin, remember, you can only have one VPC with the link local join one Lattice service network. But now with this endpoint service, it allows you to expand on that a bit more. That's one of the things I like.
And that's exactly this slide right here. So if I change it now, if you look at this original one that's just showing one service network per VPC, now that we support multiple now that we support VPC endpoints, you can actually attach multiple service networks to a VPC. Now, originally, we didn't necessarily recommend this as like, hey, you need to do this, because again, VPC Lattice services and resources, they can attach to as many service networks as you want. And so it allowed you to kind of shape a service network for a VPC. But what we got feedback from a lot of customers on is just like, that's great. I get it that I can do what I need to do. It's just, what if I have a team that wants to own the management and consolidation and all that kind of stuff, and they just want to share the service network? I don't want to deal with all the mixing and matching. I just want to share the thing that I own. Like maybe it's all the PCI applications. Maybe it's just all of the applications from a certain team. Can I do that? And so we came up with this ability to do that when we came up with the VPC endpoint support. So now you can do both, right? Access it from on-prem, access it across regions, and have multiple service networks per VPC.
And I just want to also add too, is one of the things that was highlighted, and I did paste the YouTube link of the breakout from reInvent. It also gives you so many more possibilities of integrating with your traditional networks, right? So you can do crazy things like egress through a NAT gateway with it, or you could, it's just, think about, you're now adding an IP to this service network, and everything you can do with an IP applies. Well, most everything, right? I mean, let's not get crazy. We're still in the cloud, but there are customers now that I've been working with that have been telling me some pretty cool new usage patterns that I didn't even think of because of this. So I think that might need to be a show sometime later on, Justin. Like all the crazy new things that you can do now.
I'm just seeing TechFuel's a question.
Good blogs.
Oh, sorry. Go ahead, Justin. I interrupted you.
I was just going to say, on that same front, once I hand over to Yves, I'll populate a few different blogs. I'll send them over the chat here so that you can see them.
Perfect. Yves, are you going to
Yes,
talk about TechFuel's question?
Exactly. Yeah.
Let me pop that up.
Yeah, that question is, so if you connect to RDS from the consumer account, then you expect the RDS DNS name to resolve to the VPC endpoint address or to the address of the service network if you use the DNS name or the original DNS name of RDS. However, in your question, you're saying that you were using DNS-based lookups, so a DNS resource config. In this case, we are not automatically plumbing a private hosted zone into the consumer account. This only works if you use ARN as a target instead of DNS. And then you will also have to put the check mark when you create the VPC endpoint in the consumer account to resolve the DNS names locally. So those two things, it needs to point to an ARN instead of a DNS record. And so the resource config needs to be an ARN-based DNS config. Resource config, and the VPC endpoint needs to have that checkbox set.
I also wonder, you have a demo of exactly this in both cases, right? With the Vitesse and with
correct. However,
RDS,
in my
right?
demo, I'm actually not mapping the original name of the RDS database. I'm rewriting that because like RDS doesn't care what its name is. It doesn't, like in MySQL, you don't transfer the name in the connect or something like that. And
Right.
so I just mapped my own DNS name to the VPC endpoint IP.
Yeah, I'll share with folks. I mean, there's a couple things here. So right now, you heard the term ARN, and I do want, it'll make more sense when you do see Yves kind of show it, but you heard different target types, right? And so when you create this TCP resource, this VPC resource, you have a couple different target types. You can do IP address targets. You can do DNS-based targets like we talked about. And then you have this ARN target. And ARN is where you have native AWS service integrations. Right now, it's limited on which services we support, but you can envision that this is going to be all services eventually, especially the database, data-centric workloads. So today, if you want ARN, you get RDS, right? And so if you have an RDS database in a centralized account, maybe there's some team that manages the database and it's in a different VPC, and you want to share that with everybody. This is like absolutely everyone wants this, right?
Yeah.
Especially if it's an IP overlap type thing. This allows you to natively, instead of going and figuring out the DNS and all that kind of stuff, no, you just actually get the ARN of the DNS cluster, database cluster. You put that as the resource configuration. And that will go and handle all of your configurations. So right now it's just RDS, but we're constantly working with all the different teams to try to get them ramped up to support this as well. Same goes for the DNS stuff. Today, we don't automatically populate and manage some of the hosted zone configuration in the client side. You would have to do this. But of course, that's something we're working on as well.
And for the ARN too, just for folks who don't know, AWS resource name, is a name or number?
It's name.
Name. Yeah. That's what I thought. See, someone had asked if we had our certifications. I do. I have one. I promise. But yeah. So the other thing too about the ARN that's really important is when you're creating within this new kind of endpoint support, we call it a resource configuration, and that resource configuration is where you're listing out all those resources that you want to share to your service network. The ARN will actually help handle the expansion and contraction of your database, of your RDS database, relational database service on its own. Whereas if you were to do this with the resource config without the ARN, if you're expanding and contracting, you need to figure out a way to populate that config. Also, one other question too, actually not question, but more a statement, Kareem Jamali had brought up before about, hey, you know, because now that we can do our connectivity to VPC Lattice this way with our endpoints, why would I want to do the link local? Why would I want to do the old mode? I have some answers for that, but as you are the godfather of Lattice, Justin, I want to give you the first crack
at it. Can you put that up there one more time?
Oh, sure. Sorry.
Flexibility to connect multiple service networks and being routable from on-prem. I was thinking, why would someone use the original VPC attachment mode? So interesting, and it surprises me how often I actually get this question too. The security feature of the original model and the simplicity of not having to have a VPC endpoint or ENI is easier, it's more secure, and it's cheaper. So that I would say that actually for almost all of your workloads, all of your VPCs, you would use the original attachment model. Then you would probably spin up a new VPC for centralized ingress, and in that one put the endpoint, right? So if you have a centralized VPC, just one of them, where you have a VPC peer, or it's attached to Cloud WAN where you're routing things across regions, and it's also attached to Direct Connect and on-prem, I would put your VPC endpoints in there and make them reachable, centralized. Of course, it's not unsecure. I don't mean to say like one's more secure than the other. It's just, it's a defense in depth strategy, right? If you remove the ability to connect from outside, it is going to be more secure, right? It's one less thing that somebody can do. And so unless you have the requirement to access from on-prem or have multiple service networks, I would totally use the original model. That is, we still believe in that design.
Exactly.
Now, the other thing I would point out is don't be scared like, well, I got to pick one versus the other. What if I pick wrong? These can live in conjunction with each other. You can have the original model with new ones as well. And so I would say no matter what, start with the default kind of original model. And then if and when you need the others, you can always add it in later. It's not a one or the other. It's one and the other.
Now, I'm going to ask a question, and either one of you can, of course, answer this. And this is one I get all the time, and I'm sure you guys get it all the time. And I didn't see it asked here yet. So Justin, Eve, I have Transit Gateway. So will this work with Transit Gateway? Does it replace Transit Gateway? What's that landscape look now that Lattice is here and now that Lattice supports TCP?
I would say the
really
answer is yes to both, right? I mean, it can replace Transit Gateway if all that you transport can go over VPC Lattice. And can in this case is if you configure all of your resources being either TCP-based or HTTP-based resources, then you don't need TGW anymore to route things. But if you have an existing TGW deployment, and specifically for a couple of services where you want to add things like enhanced authorization and authentication with IAM and those kind of things, you can do that with VPC Lattice and still run the rest of your traffic through Transit Gateway infrastructure.
Awesome, thank you. Now we're about halfway into the show. So I just want to make sure we can also keep along it. Love the questions coming. I love the interaction. But I also want to make sure that Yves can do the dog and pony show as well. So.
Cloud WAN, cross-region private link, TGW, VPC peering. If you can get into the VPC and access that private IP address via the VPC endpoint, you can connect to it. There's no restriction there. So whatever you want. I've seen models where customers are doing, a cross-region private link in a different region with an IP target to the VPC endpoint, things like that. So there's all different kinds of models that customers can do as long as you can get to that endpoint IP.
Right.
Okay. Should we have a look at the demo and then continue answering questions? So.
Yeah, let's do that. So I'm going to, are you finished, Justin? Any more slides?
Nope, we can jump right into it. These were just kind of high level. I cut some from the Chalk Talk, but those were the main ones I think that are interesting.
Sure. Okay.
Okay, so let's have a look at the demo. So 2 pieces. One is the ECS native integration. The other one is the TCP services. The ECS one, as you saw in Justin's slides, is relatively easygoing and easy to configure. Now, let me just quickly explain the demo setup. So I'm using the Cloud Shell to call the HTTP API of a front-end service running on ECS. And to reach that, I'm using an ALB. So it's the usual ALB integration of ECS that exposes my front-end service running in an ECS task. And then that front-end service has the capability to call my backend services. And I have two backend services. One is the catalog int example.com. The other one is the card int example.com. And those are my two services also running as ECS tasks. So let's have a quick look at the ECS cluster here. And then we'll see there's my front end. And if we look at the front end, you see that it has a load balancer attached to it, right? And so let's quickly call that API. So this comes back from my front-end server. And here you see that I'm mirroring back the request headers that I received from the client side. And so this is actually the IP address of the Cloud Shell. And this trace ID and things is what is getting added by the ALB in this case. Okay, so let's look back at the service and look at one of our backend services. Here's the backend card service. And if we look at configuration and networking again, so first of all, at the base page, you see that there is no load balancer anymore here because we are using VPC Lattice for the internal communication between our front end and the back end. And in the UI, we can find it as a specific section down here in the configuration where, as Justin said earlier, this service is attached to a specific target group, which is backend card on the VPC Lattice side. And we can also see which service it's attached to and which service network it is in. And so if we look at the VPC Lattice side on the target groups down here, then we see we have the backend card, and those are my targets, which is just one of the ECS tasks, right? And that's basically it. If you configure it from the UI, from the console here, then it will automatically add the target group to VPC Lattice so that then later on you can add that target group to the service. If you configure it through the API or through something like Terraform or any kind of automation, then what you actually do is you create the target group first on the VPC Lattice side, and then you add the ECS task to it. It's just on the UI, it basically automatically creates the target group for you. Okay, so then let's call the backend. To do this, I sent a post to my front end saying, hey, please request the backend URL. And then my front end will call this URL. And you see this is the backend card responding. And here I want to point out a couple of things. So first of all, the request came from 169.254 address, which is the VPC Lattice service network IP in that target VPC where my tasks are running. And I also want to point out those Amazon Lattice headers that we received. This is actually a feature that was added before reInvent, I think mid last year. And that is that VPC Lattice is adding information into headers so that our target can make sense of it. So our target can use this information to know from which source VPC it came, what the Lattice network was. And what I don't have here is any authentication authorization. If I would have it, then you would also see the role that was used to authenticate. And if it would be something using IAM roles anywhere, then you would also see the certificate information, the metadata of the certificate used to exchange the certificate against IAM credentials. So that's pretty cool because now on your back end, you can take additional authorization decisions based on those headers. And so, yeah, I can also obviously post a request to the catalog service and then get the catalog service back. Any questions that came up on the ECS integration part before I just jump to TCP resources?
Nothing yet, but if anybody does have a question, please bring it up.
Justin, anything you want to add?
I'm glad that there's no questions on this one, because to me, it's like the questions should have all come for the ALV integration. I'm so glad that this feature just was like out of the way.
So easy.
We now support every single AWS compute service. So that was a huge milestone for me. And I was so sad that we didn't have ECS at launch, but this rounds it out.
Also, is that the banner command that you're using in the Unix? I noticed the front and back end card. Anyway, that's
it's actually a Python feature, or not a feature, Python thing that I installed that is actually called Star Wars, and it gives back Star Wars characters. So yeah, it's just playing.
I'm totally going to steal that, because that's a really smart idea.
Yeah, that container actually, Jamie, is at least internally available. I'm still working on posting that to every AWS samples at some point, so that people can also play with it externally.
Perfect.
So yeah, one thing I wanted to add is here, this card and catalog. Those are CNAME records pointing to the VPC Lattice generated service names. So if we look at VPC Lattice, those are the services for the card and catalog. And you see it creates an internal domain name. And this is what you put into Route 53 or any kind of DNS to point to the actual backend with the custom domain name that you set there. And obviously, then you can also set a certificate. In my case, I'm just using a wildcard certificate for the service, as you can see here, star.indexample.com, which is one certificate for everything that is happening internally. If you want to migrate, actually, there's a blog out there on how to migrate from an ALB internal setup to VPC Lattice. And it's as easy as creating or connecting the services to VPC Lattice. And then switching that DNS record from the alias that was pointing to the ALB to a CNAME or an alias that you can also configure through the CLI to the VPC Lattice domain name. Okay, so then let's talk about TCP services. So obviously the question is now, how do we connect using TCP for that card service and catalog service? So if we want to talk to backend databases like we do oftentimes, how do we do that without having a transit gateway or VPC peering or any kind of routing between accounts and VPCs? And this is what we enable now with TCP-based services on VPC Lattice. And now that's going to be a bit of an eye chart, because it has both the VTest part and the RDS part. I hope it's big enough. So the first thing that you create in the producer account or provider account is the resource gateway. And this gives you ENIs in your VPC that can be used or that are used to connect to your backend services. In this case, up here to the RDS database. And here I'm using a resource configuration that points to an ARN, as you will see, so the AWS resource name. And that resource configuration is then shared with the consumer account. And then I can attach that resource configuration using a resource association to the VPC Lattice service network. And that's where it then is available to be consumed through VPC Lattice. Now, in this particular demo, I have a VPC endpoint that I created in the consumer account that is used to access the VPC Lattice network. The alternative is to use the pre-existing way, which is the link local addresses, the 169.254 addresses. So let's look at this part first, and let's look at the configurations. So here's my RDS database. It's a single database host with this DNS endpoint name. And what I'm doing here is, is here I created a resource configuration using the ARN. So this is the resource definition, and it uses the on as the target. And so when you do this, what actually happens under the hood is that it creates multiple childs for you automatically. And this is the child for database 1. So as we said earlier, if you, I think, Jamie, you were saying that if you grow the database, if you add database nodes, it will actually automatically add child resources to your resource configuration. Now that resource configuration, I'm sharing via RAM to the consumer account. So over here, we can see that, let me go here, that we have this resource configuration RDS on that actually ended up being in the consumer account because I accepted the RAM share. And so the next thing I did was in the service network, which is this one, I associated that resource configuration. So now RDS is part of the service network. And now the last missing piece is how do I actually access it? And for this, we have our endpoints. And on that endpoint, ECS service network endpoint that I created, you can see the associations here. And if you scroll to the right, then you also see the DNS names that were created to reach our resources. So each of the resources in each of the childs gets a DNS record that we can target. And as we said earlier, if we automatically enable the mapping of the DNS names, then my database name that was generated on the RDS side will also automatically be added to a DNS name in a private hosted zone here. But here in my demo, I'm actually just mapping that DNS name to an internal name for my database. So here we have rdsintexample.com, and you see it maps to that long DNS record that points to the IP address of my endpoint. So if I do a dig and for that long DNS name, you will see what we get returned is an IP address in that VPC, in my consumer VPC, that points to the RDS database. And if I now do the post again to my front end, requesting the backend get items table card, what happens is that now my backend is talking to RDS and is getting the database entries from RDS through this resource gateway link. That was a long one. So maybe you can pause for a second and take any questions, if there were some. Oh, Jamie, you're on mute.
It's funny. I have one of those mechanical keyboards, so every time I do any type of responses, everyone can hear it, so I have to mute myself first. But as you can see, there's a question here. Can the URL of the endpoint be used for things as discovery of an API that is hosted in the VPC? Is a question.
Can the URL of the endpoint be used as things to discover an API? Indirectly, yes, because you can just query the endpoint and get all the mapped entries. And with that, discover them, right? So yes, and there is the service network itself through its API, or VPC Lattice itself through its API, is able to give you a service discovery element that maps names to those generated domain names.
Very cool.
Okay, so let's finalize the demo. Now it gets even more interesting, which is the bottom part here. So resource sharing with ARN, as complex as it seems, is actually pretty easy. You just point the resource configuration to the ARN, and then it creates all those childs for you, and you get it mapped. You even get it mapped with your own private hosted zone if you check that box on the VPC endpoint configuration. Down here, what I'm doing is I'm exposing a VTES database running in a Kubernetes cluster through a Kubernetes headless service via DNS. So the way it works, and let me go here and explain VTest first. So VTest is kind of it's a CNCF project, and it exposes SQL database like MySQL through running in Kubernetes pods through what is called the VT gates. The VT gates are kind of proxy servers that are in front of the database, and they distribute the database calls on the actual pods serving that database. And those VT gates are exposing the database both over gRPC and over MySQL. And then your applications can talk to that database over the VT gates. There is control plane there that I won't explain, but let me pull that up here. This is actually the real thing. So you have the VT gate here, which has 2 pods in the cluster. You have the VTest operator, which is this control plane, but you also have external DNS. And external DNS is taking what it learns from Kubernetes services and ingress resources, and also gateway API resources, and plumps that into an external DNS server, in our case here, Route 53. And so what I did is I created a headless service for the VT gates. Headless service means I'm not putting in an internal cluster IP. I'm really just doing using it for DNS purposes. And oh, not found. What did I do wrong? I'm only using it basically to learn the endpoints here. And you see we have those endpoints exposing MySQL. And those endpoints, those IP addresses, are actually the pod IPs in my VPC. I'm using the VPC CNI in Kubernetes here. So each of the pods gets an IP address out of my VPC, and they're reachable in that VPC. And so what happens now that external DNS, as you see here, plugs in that name, what it actually does in Route 53 is to add the pod IP addresses to the DNS record as a multi-value record. And here you can also see that it's actually really the external DNS that plugged those IP address in the record. So now what we can do is in the resource configuration, let's go to the resource configuration, VTest DNS here. I'm actually just pointing to MySQL vtest-fauser.org, which calls this record. It returns those 2 IP addresses. And what will happen is that VPC Lattice will now send the traffic for a session that gets opened to one of those 2 IP addresses returned by querying the DNS name MySQL vtest-fauser.org in that provider VPC. So let's go back to our drawing. So we come here, we talk to that VPC endpoint. It gets sent over VPC Lattice to the provider VPC. It exits the resource gateway and goes to one of the VT gates. Right? That's the whole magic. So let's resolve, first of all, the other VPC endpoint here, which is the one for the VTest database. So again, it resolves to one of those IP addresses. Can also here in the endpoint see that this is the second endpoint, which is for our resource config for the VTest database. Yeah, and then we can just again call the backend. In this case, we'll call the catalog, and the catalog one is configured to talk to the VTest database. And here comes our records out of the VTest DB that runs on Kubernetes and is called through DNS. I know that was a lot, so maybe there are some questions we want to talk of.
Yeah, definitely. I've got a couple of them here. Mr. Neuromancer has asked, I'm wondering where did it come from the need to share the resources via RAM? According to them, it's a bit more of a complication. Justin, you want to take this one, or you want me to take this one?
Sure. And so RAM is really only for sharing across accounts. You don't need to use it if you're in the same account. But
Correct.
RAM by default, so in AWS, you can do a whole bunch of different things, right? When you're a service team and you're building a product, you could go and do stuff yourself if you needed to. But if we did that and we built our own cross-account sharing mechanism, we would have to go down and try to reinvent all the different security tooling and compliance tooling and audit checks and additional policy that is already built into the product that's made for this. So Resource Access Manager several years ago came out, and it was limited on what it could share. We're still adding things to it constantly when it makes sense to share things across accounts. But they're constantly releasing new tools to do auditing and cross-account prevention and new alerting, so that you have these things that are telling you and making sure that you secure things through the account boundary. Again, we like to think about VPCs as a network level boundary, and we like to think of accounts as a permissions level boundary. And so we really want to make sure that you have the tools and security controls when you're doing anything across account. And so that is why we use RAM for this. And there is a little bit of friction. It's on purpose, right? Like, we want you to think about, I am sharing this resource to somebody that might not be me. So those are why we do that. Maybe 2 years ago, we right after we launched Lattice, essentially, we came out with RAM came out with a feature called managed permissions. And what this allowed you to do is, instead of trying to figure out the IAM permissions on the destination side, you could actually attach a permission to the share and set what this person's allowed to do with the resource you're sharing, such as when I share this thing, service network, a service, are they allowed to attach it to their own service network? Are they allowed to join a service network to a VPC? Are they allowed to put new services into it? And so, like, you can do all this stuff with IAM, but it's in many places, especially if you have a lot of accounts. RAM makes all that drastically simpler for you. And so it is a very powerful tool if you're doing anything across account. And that's why it's there.
Yeah. My original demos used a single account to show everything. And then I was always asked, okay, but does that work across accounts with RAM? And so I changed the demos to use 2 accounts, which, yes, complicates things, but shows more the real thing, because we always have more of a team that manages a networking account and then other teams that expose those resources. And that's simply more realistic.
The other thing too, I always like to kind of have folks think of it this way when I get asked. With VPC Lattice, there's a lot of sharing and permissions and things that you can do back and forth within the service itself between different services. RAM is more for sharing constructs back and forth between different things. So, think of it as this way: it's like you're sitting in the car and you can pass things back and forth between the front seat and the back seat to your kids or whatever as you're driving, right? RAM is sharing that car. Now you're going to a rental service to get another car. So you're basically sharing the construct itself. And that should be kept as separate pieces on either side. As Justin said, you want to be absolutely sure of what you're doing, especially when you're doing with things that you're paying for, or sharing things that you're offering to different parts of your application and your service. That needs to have a bit of a delineation there. So we've got.
I'll add one more thing on that, is on Dominic's question about the RAM thing. To your point about constructs versus connectivity, there is a way that you could enable connectivity to a VPC Lattice service across accounts using VPC endpoints, right? Like, if you had a VPC peer to a VPC in a different account, and it's connecting to that VPC endpoint that you're exposing, right, that could work. Also, if you have a shared VPC, aka you have a VPC with a shared subnets, we do support shared VPCs and subnet sharing. And so you could have a client in one account connect to something that the VPC is associated with. Both of those will work. It's just when you're sharing the constructs of things so that account can consume it and manipulate it however they want to, that is where RAM comes into play.
There we go. And Justin, I know that you have something to share with us.
Yes. If you have your phones handy, I don't know if you can do this on your laptop or not, but here's the QR code that pops you into all of our latest blogs. And so a couple of different ones around VPC resources, the DNS targets, cross-region connectivity. If you even probably just looked at the top, 5 blogs or something like that, you'll come across all the latest ones. And I think those are all pretty good. But I would say there's a whole bunch of great blogs in there. So it's good, not even late night reading. It's good mid-afternoon reading.
Awesome. And also check out theroutingloop.net for future episodes. I saw some questions up there. Thank you, Yves. Thank you, Justin. As always, hope to have you guys back on the show soon, and have a great day.
A good one.